Hi, this is BRR. In this video session, we'll discuss about the session affinity on load balancer. So, what is this session affinity and how it is how it is being handled on the load balancer configurations? So, what is this load balancer? As I explained you in the earlier sessions, load balancer is nothing but distributing network traffic across multiple compute resources and sharing this traffic request to multiple web servers to gain the performance. So there are a lot of load balancers available in a market like Citrix and Cisco and AWS and Azure. I know, there are a lot of things we have, but we'll discuss those things in later sessions. But what is the session affinity on load balancer? So when you have multiple servers configured with a load balancer, how the session is being shared and how the session is being protected and processed, being multiple requests to the web servers. If you configure multiple instances in the backend of your load balancer. So because if you configure load balancer, we have a lot of things can be considered. If you look at the diagram here, so I have different, the users which are browsing my web application from these machines which are having IPs 1, 2, 3, 1, 3, 2, 3, 3, 3, 4, and this is what the internet. So via internet, I'm able to access my computer resources from the cloud. So this is what the load balancer. I'm putting it here before my actual web servers accessing. So what the load balancer is doing is this will take the request from the users and it will distribute the request to the web servers based on the the availability of web server after the load balancer hit the health check to the web servers in the round trip of the configuration time to send the health request, health ping to the web server. If it responds properly and being pinged properly, then it will send request to the relevant web server through a load balancer. So again, in the load balancer, it has some the rules and targets here. Like targets contains the what are the EC2 instances. Like look at the AWS server, the EC2 instances, Elastic Compute Cloud instances being referred as web servers here. So what are all the targets has been configured through this load balancer, and the protocols and the SSL certification details and the some of the configurations like session related or cookies related or the cross domain access or internet or external users access. So numerous things can be configured using the target section. So it has target section in the load balancer. At the same time, it has some rules section where it has certain rules being followed by the load balancer when request receives from the browser via internet, and before it sending to the EC2 instance which are configured behind this load balancer, it follows the rules and guidelines in the rules section. So when the request comes this particular browser to this load balancer, what it will do is it will have create a lookup table here and put the client IP and server IP here. Like let us say like the request comes from 1232 and load balancer process this request from 9123 web server. So before sending it to the web server, it will prepare some table here in the load balancer itself, like the mapping table. Like this is the IP request. This is the request comes from this IP, and this request has been processed from this particular EC2 instance behind the load balancer. So like that, it will prepare some lookup table here so that it has some tracking information. Again, when again post request or similar request is happening through a similar IP, and it will send it to the same web server. So this way it is maintaining it. But if you deploy in the internet world, and numerous users are going to access on concurrent basis, like if you look at the Facebook or Google or Yahoo or any social network or any LinkedIn or kind of thing. So many people, million of users are going to access every day. So million of people's been sending a request. So the million of people's having individual IP addresses. This is not worthy to maintain all IP addresses in this particular lookup table, because it increases the things in the lookup table, and it is again burden on balancing the load on request. So this might be the biggest problem in the load balancer to maintain all these things. So what it will do is to resolve this problem. So if you look at every organization or every website which is being configured on the public domain, they will be creating an ISP providers, that is what internet service provider service proxies, before sending the request to the direct internet. So they configure proxy to the users, and the, like, let us say, like organization one have some organization proxy server where the organization one request being processed through that particular ISP proxy. Like this, if you look at these three users being processed through this ISP provider, this is what the proxy server. So that if this organization having like lakhs or thousands of users, they will be definitely come through this particular proxy server, so that I have only one IP address when I reach to load balancer by an internet. In this case, instead of like maintaining all these IP addresses, I maintain only 5432 IP address. It refers the requests are being comes from this particular organization or particular provider of request. So this way it is being the balanced the load when processing multiple requests or multiple browsers being processing the request via load balancer. So like that we'll be having each and every organization and ISP provider proxy. So the way the requests are coming through this particular proxy servers. So in the lookup table, if you look at here, this only refers the proxy address, but not all individual IP address of the browsers. This is not mapped to any proxy, so this will always post this lookup table with this actual IP here and corresponding server IP where it is being processed. But this way also we have a problem, like users are increasing it. Then we'll consider the picture like multiple ISP server proxies where it has multiple internet service providers. So like this way, so the request being comes through this particular proxies, and this lookup table is being referred this particular proxy addresses only instead of like actual IP addresses, and the server IP addresses are mapping here, and that information stuff is being maintained in the load balancer as a global stuff, so that it knows the request before sending to the browser. But then when I have a, like if you look at the same diagram here, 5481 and 5482, like 5481 is coming through here, 5483 is coming to this particular thing. But here 5482 also coming this particular through two of the multiple ISP addresses. But if you look at this, my lookup table, I have only these particular IP addresses, but I'm not sure like from which browser my request is coming from and what is IP addresses. Like the session is being created when initial request is landing or initiating in the web server, then session is being created and sending response back to the client. But when similar URL or similar browser when sends another request or post back request to the web server, so it has to maintain same session, otherwise session will bounce and we lose the session and it will goes to the login page, and things will get goes in wrong way. So how we are going to resolve these particular problems? So this is where the session affinities comes into the picture, because you are having this map server proxy addresses here and server IP addresses here, but not the actual IP address of the browser having it. But how the session is being sharing and session is being protected between these particular requests. This is the area where the affinity is coming out, and session is bouncing, and the stuff which you are keeping in the session is being lost or changing and giving wrong results and putting the wrong perception and metrics on your web response coming from web server. So now how you are going to correct that problem? So if you look at the AWS, we have a session ASP.NET session stickiness enabling process. If you can enable that particular ASP.NET stickiness configuration, then it will maintain this cookie string of ASP underscore ASP.NET underscore session ID cookie in the URL itself, and same time the load balancer will maintain the global string with this the session ID respect to the IP address, so that the same cookie string will process to the browser as well as to the web server. This way you will protect the session and will resolve session affinity problems here in this load balancing. Like this is what the another screenshot you can see here, like what are all the configurations you may see in the AWS server when you create a load balancer for your web servers. So this is the screen you will get once you initiate the edit stickiness here. By default, it is disable stickiness. If you enable application generated cookie stickiness, so the cookie name will be created like this, and this cookie will be transformed along with your request, and it maintains the session. and no bouncing will happen, and this way you can protect the session and resolve session affinity problems. So hope this is clear, like how session is being bounced and affinity problems occurring while you creating a load balancer for the multiple web servers and seeing like multiple requests coming from the multiple ISP proxy servers to the load balancer. So this clears like what is affinity problems in the load balancer. Thanks for listening this, and please watch on YouTube channel and subscribe this for more videos on this.